This video deals with the Cartesian coordinate system, and this system is essentially used for the representation of points on a graph. What is a graph? Well, with respect to the kind of graphs we're going to be looking at, a graph is a diagrammatic representation of the relationship between variables. The lines and curves you've come across in your junior secondary school, the lines you've plotted and those curves, they are all plots of equations. When you plot an equation, you get a graph. And for an equation involving two variables, the equation is itself a representation of the relationship between those two variables. And this will make sense shortly. Consider the equation y equals 2x. The variables in this equation are y and x. The equation is itself a relationship between the variable y and the variable x. How? Well, this equation says that y, whatever the x value is, y is twice that value. The y value is equal to 2 times the x value. That is the relationship. So for an x value of 1, y has a value of 2 times 1, which is 2. For an x value of 3, because of this relationship between y and x, y has a value of 2 times 3, which is 6, and so on. So this equation tells you the relationship between the variable x and y. So when x is 1, y has a value of 2. So I'm using this xy representation, which is the Cartesian coordinate system of representing points, but we'll get to that shortly. And the other point is 3, 6, so x of 3, y of 6. Now, all these points and many more will give rise to the plot of this equation, but we'll see that shortly. Let's just look at the other equation. This equation is the equation y equals x squared plus 2x. It's a different relationship between y and x. When x is 0, y is x squared plus 2x. So 0 squared plus 2 times 0, which is 0. When x is 1, because of this equation, this relationship, y is equal to 1 squared plus 2 times 1, which is 1 plus 2. Y is equal to 3. So for this second equation, we have the following point so far, 0, 0. We also have the point 1, 3. When x is 2, because of this relationship, y is 2 squared plus 2 times 2. Y is 4 plus 4. Y is 8. So that's 2, 8. So the first value I'm writing within this bracket is the x value. The second value I'm writing is the corresponding y value. And this representation of points that satisfy equations is the Cartesian coordinate system of representing points. Method for representing points in the Cartesian coordinate system. Let's put it that way. So now we're going to quickly review graphical axes. You've come across this in your junior secondary school. You have plotted graphs before. But let's just quickly review the key concept. The horizontal axis is known as the x-axis, with the right hand half of it called the positive x-axis, so plus x, and the left hand half known as the negative x-axis, labeled with minus x. The vertical axis is known as the y-axis, with the top end known as the positive y-axis and the bottom end known as the negative y-axis. The axes are calibrated, and you can have numbers on the graph. So you can have something like this: 2, 4, 6, 8, minus 2, minus 4, minus 6. Notice that negative numbers lie on the negative x-axis and positive numbers lie on the positive x-axis. And then moving on to the positive y-axis, we can have something like 2, 4, 6, 8. As you can see, on the positive axis, there are positive values, positive numbers. On the negative y-axis, we have a negative number. So here's a graph whose axes are calibrated with a step size or an interval, an interval of 2. Every number, as you move to the right, each number increases by 2 units. So 2 goes to 4, plus 2 goes to 6, plus 2 goes to 8. Same thing, 2 plus 2, 4, plus 6, 8. Again, that's for the x-axis. For the y-axis, numbers increase as you go upwards. So minus 6 plus 2 is minus 4, plus 2 is minus 2, plus 2 is 0 at the center. And that brings me to this center point, which is known as the origin and has the coordinates 0, 0 in the Cartesian coordinate system, where the first 0 refers to the x coordinates and the second 0 refers to the y coordinates. But we're going to get to these shortly. The key thing to note in this video is that this center point is known as the origin. The vertical axis, so this vertical line, this whole one here, is the y-axis, and the horizontal axis, this one extended from left to right, is known as the x-axis. The right-hand side is the positive x-axis, the left-hand side is the negative x-axis. For the y-axis, the top end is the positive y-axis, the bottom end is the negative y-axis. For the x-axis, numbers increase as you move from left to right. For the y-axis, the numbers increase in value as you move from bottom to top. In this video, we're going to look at the calibration of the y-axis. Now, if you recall, the center of the origin of any graph is located at the center of the y-axis and the center of the x-axis. So if I just quickly scroll back to this graph, recall, look at the x-axis. At the center, you have the origin, and at the center of the y-axis, you also have the origin. So if we go to the center of this graph, we can mark this as the origin, and at the origin, the y coordinate is always 0. So I'm just going to mark this with a 0. I'm going to do the same for these other axes. Now, when calibrating axes, step size or intervals are used. So for instance, I could say I want to use a step size, or let's just use interval. An interval of 2 units. I'm going to call it 2 units. Now, for the y-axis, as one moves from bottom to top, the numerical values increase. Here our interval is 2 units. So if we start from 0, the next point on the graph is going to have a value of 2. 0 plus 2 is 2. We're just increasing, as we move from bottom to top, we're increasing the values by 2 units. So the next point is going to have a value of 4, because 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. As we go downwards, the values decrease. So 0 minus 2, because we're going down. Minus 2 minus 2, minus 4. Minus 4 minus 2 is minus 6. So this is a y-axis that has been calibrated with an interval of 2 units. For this second axis, this one in blue, I'm going to use an interval of 3 units. Starting from 0, we increase the value by 3 units. 0 plus 3 gives us 3. 3 plus 3 gives us 6. 6 plus 3 gives us 9. 9 plus 3, 12. And we can keep going. And as you go down, once the values decrease, so we decrease by 3 units, we subtract 3 from 0 to get minus 3. Subtract 3 from minus 3, you get minus 6, minus 9, and so on. So here's a y-axis with a calibration interval of 3 units. Now note, the spacing, these spacings, are all 3 units in value on your graphical axis. But the key thing to note is that when you actually plot them neatly on graph paper, the length of these heights should be the same. This is just a rough sketch. Anyway, now let's move to this last axis, and let's use another common interval, 10 units. Starting from 0, the values increase as you move upwards. So 10, 0 plus 10 is 10, 10 plus 10, 20, 20 plus 10, 30, 40, 50, 60. And as you go downwards, values decrease, and our interval is 10 units, so we're going to decrease the values by 10 units. Minus 10, minus 20, minus 30, minus 40. So let me just point out, the interval here is 10 units. 50 plus 10 is 60. All these intervals are all intervals of 10 units. All 10 units. Same thing here. All these spaces represent intervals of 10 units. Minus 40 plus 10, minus 30. Minus 30 plus 10, minus 20. So 10 units. Here all the intervals have a value of 3. And here all these intervals here, let's just represent them in this, have a value of 2 units. This is just revision for you. This is something you've done in junior secondary school. So let's move on to the calibration of the x-axis, which is a very similar process. So here's one x-axis. Say the origin is at the center. We have a value of 0 at the center. Let me just make note that the origin doesn't always appear on the center of the axis, but just for the sake of demonstration, for the y-axis and x-axis, I'm going to place the origin at the center, and at the origin the x coordinate is 0. So here we have 0. So I'm just going to put 0 somewhere in the middle. Now, if I want to calibrate this x-axis with an interval of 2 units, I know that for the x-axis, if you just follow the arrow, the values increase as we move to the right. And they're going to increase by intervals of 2 units. So 0, the next value will be 2, the next value will be 4, next value will be 6, 8, 10. And on the x-axis, values decrease as you move to the left. We're using an interval of 2. So values are going to decrease by 2. 0 minus 2, minus 2, minus 2, minus 2, minus 4, minus 4, minus 2, minus 6, and so on. All these intervals, have a value of 2 units. You will be doing this on graph paper, and you have done it already in your junior secondary school, so this is just revision. I'm going to calibrate the next one with an interval of 3 units. 0, the next one, 3, 6, 9, 12. Minus 3, because values decrease by the interval as we move from right to left. Minus 3, minus 6, minus 9, minus 12. Here, we're going to use an interval of 5 units. Values increase from left to right, so 0, 5, 10, 15, 20, and so on. Minus 5, minus 10, minus 15. So here we have an x-axis calibrate with an interval of 5 units. Here, an interval of 3 units has been used in the calibration. And here, an interval of 2 units. This is really easy stuff, and this is stuff you've done before. But this is just a reminder. In this video, we're going to look at how to determine the x-coordinate of a point. So here we have a graph. Here's the y-axis. Here's the x-axis. And there's a point A here labeled. In order to determine its x-axis, one just has to draw a vertical line down to the x-axis and read off the value you get. Here we have 10. That means the x-coordinate of this point A is 10. And as you can see, 10 is the horizontal displacement of the point A from the vertical axis. And that's what this 10 represents, a horizontal displacement of 10 units. But anyway, just to determine the x-coordinate, just draw a vertical down line from the point to the x-axis and read off the value you hit. To determine the y-coordinate of a point, so the same point A, to determine the y-coordinate, one draws a line to the y-axis. So what line can we draw to the y-axis in this case? A horizontal line. So one draws a horizontal line to the y-axis, and the value one hits, one reads off as the y-coordinate of the point. So far we've determined that point A has an x-coordinate of 10 and a y-coordinate of 8. Very simple stuff. And you can see the y-coordinate is just a representation of the vertical displacement of the point from the x-axis. Not to worry too much about that. Just the key thing is, if you want to determine the y-coordinate of a point, you draw a horizontal line. You draw a line to the y-axis, and that line will be a horizontal line, because that's the line, a straight line that takes you to the y-axis. And you just read off the value you hit. Simple. So here's another graph. This time we have a point B. As you can see, point B. To determine the x and y coordinates of this point, we use the rules that I just discussed. To determine the x coordinate, one just has to draw a line to the x-axis to determine the x coordinate. And the line we draw is a vertical line. So you use a ruler on real graph paper, and you get to a point here, and the value we hit, you read off. In this case, that's minus 3. So you just read that off your graph, your axis. To determine the y coordinate, one draws a line to the y-axis, a horizontal line to be precise. And in this case, we have a value of about minus 3 point something, minus 3.5. You will be using graph paper, and you'll be able to easily read off the value. But it's as simple as that. To determine the x coordinate of a point, just draw a vertical line to the x-axis. You draw a line to the x-axis. To determine the y coordinates of a point, you draw a line to the y-axis, and you draw a horizontal line. And you use rulers to draw these horizontal and vertical lines, and you just read off the values you get. So in this case, B has an x coordinate and a y coordinate. An x coordinate of minus 3, because that's the coordinates we read off from the x-axis, minus 3, and a y coordinate of minus 3.5, because it's a value that lies on the y-axis, and it's a y coordinate value. So it's as simple as this. At this point in your mathematics education, you would have come across a number of graphs, but this video serves to illustrate graphs as the plots on graphs anyway, as collections of points. So here we have a straight line, we have another straight line, here we have a curve. What I'm trying to point out is that this line is a collection of points. One plots an equation and gets a collection of points, then joins them up to give the line. Same thing here. If you're plotting this equation, say this was the equation y equals 2x plus 1. One will get data values for that one will plot and point these points, these data values, these points, and join them up to get a line. Here's another curve. This curve is actually a collection of points. If one were given the equation of this curve, one will use that equation to determine x and y values and then plot the points and then join them up to give the curve. And this is something you've done in junior secondary school. So I'll just give you an example quickly. So say this line was let's use this one, y equals 2x plus 1. Now, one would get corresponding x and y values based on the equation. So this equation is y equals 2x plus 1. When x is 0, y is 1. When x is 1, y is 3. When x is 2, y is 5. When x is, say, minus 1, we have y is minus 2 plus 1, which is minus 1. So we have points here. Each row represents a point. Well, let me put it this way. We have 1.01, we have another point 13, another point 25, another point minus 1, minus 1. And I've written this in the form xy, where the first value is an x coordinate and the second value is a y coordinate. These points are plotted. So for instance, let's say 1, 2, 3, 4, some of these points will be plotted on this line and they'll be joined up to give the line. You'll see this when we get into plotting of graphs, but the key thing about this video, the key idea, is that these lines that you plot, these lines and curves, are actually collections of points. One first plots points, then joins these points up to give lines or curves. That's the key idea. That's the only thing you need to take away.